This meeting is being recorded.
Okay, so we are all set and we are starting our presentation of today's topic from use of AI tools in scholarly communication from referencing to machine translation. Where most of the cases I'm going to show you live demonstration of a few tools, and we have a great start point by the lecture of Professor Molay Bhattacharya on the inaugural session, immediately after the inaugural session. So I'm starting right from there, and please someone report me whether you can see my slides or not. Although most of the cases I will be depending on the live demonstration. Uh, is it visible?
Yes, sir.
Fine. So let me keep my video feed off and let me start. So you see here that AI/ML is basically a multidisciplinary, area. It's definitely at the core of the code there is mathematics, physics, and computer science, but many other disciplines are slowly, actually fusing inside the AI/ML landscape. One of the major thing is the data science. Major, contribution, coming from data science nowadays to make AI/ML more applicable to different domains. And data science is basically leading or changing the paradigm in AI/ML from the knowledge-driven AI to data-driven AI, where you throw a large amount of data to the machine. A machine learning backend algorithm can find out pattern through supervised learning or unsupervised learning, and can predict, suggest, cluster, group things according to our choices. So when we talk about the AI/ML, one particular phenomenon always comes to my mind. That is the bamboo tree phenomenon. You see, those who are from the countryside and having a root in village, they know this fact very well. The urban dwellers may not be knowing this fact very well. That it's related with the bamboo tree sapling. When we grow bamboo tree for the first 5 years, there is no evidence that nothing is coming out. You have to wait long 5 6 years to see that bamboo tree is coming out of the soil. Then again, within 5 6 weeks, it's actually grow. It can grow up to 90 feet. So that same thing is happening presently in AI/ML. It's not that AI/ML is a new thing. As during the session we discussed this one, that it started. All of this started with Alan Turing, the father of the web, in 1950s. Then all on a sudden, when OpenAI made it public or introduced ChatGPT in the public domain, all on a sudden we started realizing at a large scale how potential this technology is. So why I am saying this bamboo tree, phenomenon, let me go outside of my own comfort zone. So this is coming from evolutionary biology, that if we check the development of human race, Homo sapiens. Homo is the genus and sapiens is the species, we all know. So this is a journey from long 2.5 million years. And in the first 2 million years, brain has given nothing particular in return. If we consider the cost of keeping brain inside a human body, when you are doing nothing and sleeping peacefully, then also 25% of your body energy you spend in keeping brain awake. So that is the demand of the energy from the brain, and it may go up to 80%, drawing 80% of the body energy when you are involved or engaged in some mental activity like writing something, searching something, calculating something. It may go up to 80%, spending of your body energy when brain is in super active format. So this is a very costly organ, in terms of the energy we gather through food. Then you see here the entire journey from different species under the genus Homo, Homo habilis, Homo erectus to Homo sapiens, how the skull size is growing here. And this skull size is basically to accommodate more and more brain matter. If we calculate this growth of the brain size from chimpanzee to the present day human being, chimpanzee is the basically the closest relative to the humans, Homo sapiens, the human species. Almost 98 to 99% of genetic codes are matching with chimpanzee. But if you calculate the brain size, it's around 485 cc, whereas the present day it may go up to 2000 cc. And to accommodate this larger volume of the gray matter or the brain matter, our skull size also it is increasing day by day in every generation. And as I said that this is a bamboo tree phenomenon, you see here the first 2 million years, brain returned nothing back in particular. Only it helped us to prepare some kind of tool. If you move from the bottom to upward in this particular slide, we started with old one tools 2.4 million years ago. 2.4 million years ago. Then 1 million year we took to make this particular blunt tools, the sharp one, double-edged one. And again, when you come to the different other historical period, the Paleolithic tools are something like this. So 40,000 years ago, we developed this kind of tools. So almost past 2 million years, brain is basically giving us this kind of tools to fight back with other animals, to break the bones of the larger animals, so that we can take the bone marrow as a nutritious food. So this was the effect of the brain. Then all on a sudden some magic happened again, like bamboo tree. If you have a panoramic view of the entire human civilization history, right from Homo habilis to till date, so you see, first 2 million years we produced that kind of blunt tool. Then we entered into the agricultural age almost 7,000 years ago. The big empire age like Roman Empire, Egyptian Empire, then many other Sumerian civilization all started in this period only 2.5 thousand years ago. The first scientific age, we are the production of this particular scientific age where reason is the god. You need to explain, you need to provide data to support your claim, your facts. So that reason based era came only 380 years ago with the introduction of the scientific theory by Francis Bacon, W.T. Harris, only around 400 years ago. Then 200 years, within 200 years of this scientific age, we introduced industrial age. Different kind of automation took place. Steam engine came into effect. So all the mechanical devices we are seeing, mainly the production of this industrial age. Then with the advent of computer, because this technology up to industrial age, we tried to imitate different human organ. It may be surprising fact to you, but if you take a serious and closer looks of any of the technology human civilization developed or built are based on our five sense organs or different kind of human organs. When you are taking a speedy vehicle or a train to commute from one place to another place, it's nothing but extension of your legs. When you are using big cranes, industrial automation, extension of hand. When you are looking a virus through your microscope, extension of your eyes or telescope. So these are all technologies up to the industrial age are the imitation of different human organ, different human capabilities. But we never attempted to imitate our brain, the most powerful and most costly device inside the human body. That we started imitating in 1970, almost 50 years, 70 years back, in 1950 with the introduction of personal computer. Then we achieved different generations of computing up to 2020. Now people are talking about quantum computing. And from 2020 onward, another age started, that is called symbiotic age, the man-machine symbiosis. Nowadays, we cannot think of our life without the help of a machine, right from the morning to the night. When you are waking up morning, your submersible pump is lifting water from the groundwater to your overhead tank for supporting all kind of morning choruses and other things. So you think about your mobile phone, how mentally you are depending on your mobile phone. Every 10 minutes you are opening mobile phone and simply knowing nothing what I am looking in my mobile phone. So one interesting survey study came that a average human being with a mobile phone open his or her mobile phone 80 times a day, and 50% of the time he or she does not know why he or she is opening his or her phone. So that is the situation, that is the dependency on the machine, and that is, this age is called man machine symbiotic age. And in 2050 people says that, expert says actually, that we will be entering into the autonomy age. And you already know that we are a semi automated society. Your banking automation, your library automation, your industrial automation requires human intervention at each and every step. When you are making an online payment, suppose to this seminar fund, now, the process of transfer of the fund is automated, but you see, every step it requires your human intervention, selection of the fund, then OTP goes to you, you need to provide the OTP, your PIN, and so on. So, every time it requires human intervention. That will not be the case in 2050, it will be a complete automation process. And from 2060, experts again predicting that we will be entering the era of tech singularity. Up to this point, up to autonomy age, up to 2060, human civilization will and are producing machines which are not smarter than a human being. We control them, we program them, we use them. But in 2060, human civilization will be able to produce, which is able to produce a machine or group of machine which will be smarter than the human being. And from that point of time, what will be the history? That's still in science fiction. Nobody can predict, but computer scientists and are working in this particular area, and popularly in the research domain, this phenomenon is called tech singularity. So what will happen after tech singularity, like a Big Bang model or something like that? We simply do not know, but that is bound to happen. One day we will be producing machine smarter than human being, and this AI ML, what we are talking now, it is still in its infancy age, and at its maturity level, where it will go, people simply do not know. Okay. So anyway, this is the bamboo tree phenomenon. First 2 million years, brain has given us nothing in return particular. Then all on a sudden, when we given scope, brain actually showing its magic. And 500 years, only in 500 years, you can see from where to where we actually reach. So before starting the core part of this presentation, let me start with in lighter mode. So up to 2019, BC stands for before Christ. So AD, Anna Domini, from the time of our God, and BC stands for before Christ. Now, can someone of you guess in 2021 what BC stands for? Because a very important event happened in 2020, 2021. So now BC stands for what? It's a joke. Any logical guess?
Before COVID.
Yeah, excellent.
Before
So
COVID.
yes, yes. So BC now stands for before COVID, because before COVID and after COVID, life is completely different. Suppose COVID was no, if it is not there, maybe this particular workshop could have been happening in physical mode. But in 2023, another very important event came, and now BC stands for what? Can again you guess?
Before ChatGPT.
Yeah. So this is before ChatGPT, because the moment OpenAI introduced this ChatGPT in the public domain, everything again changed. the way we communicate, the way we write, and basically every literate person of the world are actually wondering that what is happening. I'm giving a simple statement or a simple question, one line question, it can generate automatically one paragraph without any grammatical mistake. And although sometimes it hallucinates, but 80% cases, if I pose a generic question, it can answer it. So yesterday there was a session on chat gpt. I hope you have enjoyed that. So I do not have to explain what ChatGPT is doing, what are the different kind of precautions we need to take care. But it is actually, it has changed the way we see the scholarly communication process. And another joke is that humans are presently hooked. We are busy with different kind of infotainment devices, particularly our mobile phone. Meanwhile, machines are learning. So it's again a joke, but it's sad reality also. But anyway, this particular slide, that Professor Malay Bhattacharya took care of it. So I actually taken from his presentation this one. So here, one particular point I need to mention. You already know this history, from Professor Bhattacharya's lecture. But why myself? Because there is a two group of people who think some people thinks that McCarthy at MIT, who developed LISP, list processing, so programming language, first of its kind for developing AI based tools, is the father of the AI. And one group thinks that Alan Turing is the father of the AI, who developed that the great imitation machine. And you can see his biographical picture, that the imitation game. It's a great movie. So Alan Turing started this concept of this machine with the artificial intelligence and code breaking capabilities. He wrote a paper on the basis of his experience and knowledge in 1950, and that actually the initiation of this entire AI ML proceedings. So some people consider him as the father of AI. You can you see this, you understand, or this particular picture is familiar to all of you, those who are using web. This picture,
Yes, sir.
every time a computer, and how ironic it is, it's not it, every time a computer is taking a test whether I am a human being or not, whether you are a human being or not. So ironically, this process is called captcha, to identify that you are accessing as a human being. And you see here, we still remember the legacy of Turing in the naming of captcha, because captcha stands for completely automated public Turing test to tell computer and humans apart. Because Turing actually, way back in 1950, given a set of conditions or parameters, on the top of which you can decide whether a particular program is at par with the standard of AIML, whether it is behaving like an artificial intelligence program or not. So till date we use a Turing test, and all the tools we are discussing here, many resource persons are discussing, all actually passed Turing test, because they are now considered according to Turing parameters or Turing test. They are all qualified AIML programs. So with this brief, introduction of this history, uh, what I would like to say, that as I said, this technology is slightly different, the computing technology, because we are trying to imitate our most costly body part, that is the brain. And artificial intelligence and machine learnings are basically adapting the brain style learning based on neural network model, because our central nervous system, brains are connected to each other through the information superhighway called the spinal cord, and the entire network, the signal processing, takes care by the neural network, inside the body. So the same model we are trying to adapt or imitate inside our computing system. Although till date human civilization does not know more than 10 to 15% of the knowledge we are having presently, how brain works. we mostly know 15% of the process. Rest 85% we simply do not know. So on the top of that 15% knowledge, we adapted the neural network model and utilizing that neural network model in different problem solving through AI/ML. And that's why I said that the entire AI/ML, proceedings, the development from 1950 to till date, you can divide into two broad groups. One is the knowledge-driven AI, another is the data-driven AI. So knowledge-driven AI, what you need to do, you need to provide or feed the machine the knowledge base. Suppose I want to, I want to as day before yesterday, Professor Bhattacharya was saying the journal suggestor. I can provide the machine all kind of scopes of the journal in my database. Say 1,000 journals are there, scope, keywords, number of paper published, and then we try to group those journals into different groups. So that particular knowledge, the scope of the journal, the number of paper published, the keywords utilized by authors are acting as the knowledge base. Then you are writing an inference engine and you are having an NLP based user interface through which you can ask a question in natural language. Computer can understand that. By using its knowledge base, it can provide you answer through the inference engine. Now that was a very costly, kind of AI, because every time you need to produce a domain-based knowledge modeling for each and every problem, and sometimes it's quite impossible. So that's why after the introduction of machine learning, we are actually all the present days AI/ML are based on the data-driven, technology. That means you do not have to prepare the knowledge base, you do not have to create the inference engine. The machine learning backend will be a generic one. They are following different kind of backend algorithms. You throw the data, it will understand the pattern, and the job of the development of different AI/ML programs will be much more easier. So here one example I am giving that how knowledge driven and data driven AI are basically utilized in harmony. So in my domain, what I am going to demonstrate before you that how it works. So we need to feed an ontology. Ontology means a knowledge model on a given domain. Say for example, I want to create a classification system for all the chemistry document. So chemistry is again different kind of hierarchical division: organic chemistry, inorganic chemistry, crystallography, mineralogy. So on this, division, subdivision, subdivisions we can provide in the form of ontology to the system. Then we can provide lots of data written by different chemists, scientists, academia, in the form of paper, in the form of book chapter. We can throw it to the machine, and then we can ask question that this particular document belongs to which category of chemistry: mineralogy, crystallography, or stereochemistry. So that kind of answer we can get on the basis of this. This process is called training of the machine learning. Then after the training, I can ask a question, and it has been found that we need to finally measure the efficacy of the machine learning backend, how good or how bad it is performing. So it has been observed that 85% matching with the gold standard, that is the human index systems, are actually matching up to the 85% level. So this was the success story of the integration of data driven and knowledge driven AI, and most of the AI/ML technology are based on this generic model. So now, if we try to define the AI, many lecture already happened, and what is AI. So AI is basically, let us take a very simple statement: the simulation of human intelligence in a machine, particularly in a computer system that we all understand. And when we are talking about this AI, although we use AI and ML synonymously, these are not synonymous. You cannot use this interchangeably. So artificial intelligence is the broader domain which includes many components like NLP is a very important component, user interface is a very important component, data providing, whether you are going to provide data in raw text or in JSON format or in XML format as an answer. So that becomes a very important thing. Whether you are going to support REST API based interaction or not, that's an important thing. Server is an important thing. So it includes many things. But you see here, in case of scholarly communication process, these three, four things are very important in the outer shell of AI. That is the natural language processing, because everything depends on it. One of the characteristic feature of an AI that we need to provide question in the form of natural language, English-like language. Presently, almost all retrieval systems follows an artificial language. When you are searching Google or any database, suppose I want to retrieve all data written by a given author X on the domain on the keywords Y and published during 1980 to 1990. So what I need to do presently? Author is equal to X and keyword is equal to Y and publication Y greater than is equal to 1980 and publication year less than is equal to 1980. We need to use nested boolean to complete this syntax. So that's completely an artificial language, and searcher requires intermediary to high level of search skills or literacy. So in the contrary of that, natural language processing, I can ask a question in normal English language like what is the possibility of India to enter into $5 trillion economy? What are the future of libraries with the advent of AI ML technology? So that kind of research question I can ask in plain and simple English. Then second important thing is that knowledge representation model, how to represent knowledge, how to structure knowledge before fitting inside the machine for the training purpose. Then different kind of retrieval, how it is search strategy, what it will be, how to enter the search term, what is prompt engineering. Yesterday you have gone through that prompt engineering process, and different kind of retrieval model. So again, as I said, that ML is a subset of artificial intelligence, mainly maybe the most important component because it is doing all kind of heavy lifting job, the major job of analyzing data, identifying data pattern, but still it's a component. And in this component, the most important thing is the ensemble process. So all the machine learning backends you can divide into different group like lexical backend, associative backend. But if we want to take the good of the both world, the lexical group and the associative group, we need to mix them up, and that mixing up is called ensemble. Ensemble is an idea or concept coming from the music industry. You all know the chorus. When one is playing guitar, another is playing violin, someone is singing, someone is playing drums. So, weakness of one particular sound player may be overcome by the by another player. So all together we are producing the same. So weakness of one may be reduced by another one, and we are taking the strength of all the sound players in our music or orchestra. So that is the effect of ensemble. You can take or judiciously mixing upon this lexical backend or associative backend. So within the machine learning, again, the most important subset is the neural network subset, where different kind of neural network models are moving on. But the most important model, what most of these services and software are utilizing is fortunately open source, developed by Google, and that is called TensorFlow. So TensorFlow or Keras are the neural network model that most of the AI/ML tools are using. And again, within the neural network, there is a group, a larger, a code group that is called the deep learning, where comes the classification of this large language model, what you are presently, observing or experiencing, like GPT model, like BART model, which is now renamed as Gemini by the Google. So all comes and termed as transformer model, and this is a kind of deep learning. So this is the domain of artificial intelligence. Now, if we go to the machine learning, what it is as a subset, as I said, it is mainly doing the heavy lifting job of data analysis, pattern identification, different kind of analytical model building. And Professor Bhattacharya already explained that what is supervised learning and unsupervised learning. So again, these two are the main thing, of course. But again, an integration of these two is called semi-supervised learning, where you are judiciously mixing both supervised learning and unsupervised learning. And another new one is coming, reinforcement learning. That means reinforcement learning includes a feedback mechanism. Suppose I am using a supervised learning or unsupervised or a semi-supervised learning, then again a human, a group of human or a single human is providing feedback to the system that okay, I asked you 10 questions, you answered mostly right in for 8 questions, but these 2 questions went wrong, answers went wrong. So this would be the right answer. So again, a human, group of experts, subject expert, domain experts are, helping the machine learning process through their feedback. How many of these answers are correct? What is wrong? And what's the reason of, it went wrong? So that is called reinforced learning or reinforcement learning, where through feedback, computer or machine learning backend again learns that what went wrong and what should be the right thing. So these are the 4 machine learning techniques we are utilizing in for each and every machine learning program. So I don't want to go into details of that. And one thing is that there is a little bit of AI in everybody's life, knowingly or unknowingly. For example, you see here, the first picture talks about this, mobile phone. Am I still connected?
Yes, sir.
Okay, fine, fine. Because nowadays you see the previously Zoom or Google provide you a bar that you are connected or something like that. Now in the new application they are not giving like that. Okay. Anyway, so this is the mobile keypad. You can see I typed 2 letters and computer can or my mobile phone can predict a complete word. In case of Google, they are using that Gemini or BART. I give an input in the form of 2 lines, and Google can predict, or Gmail rather can predict what should be the third line. So I am giving a paragraph, it can guess the next line, and if I press tab, it will come. If I don't care about it, I keep on typing, it will vanish. Again, the similar technology we can integrate with our word processing. So the moment I type a few word, it can predict the rest of the words of the sentence, and it depends on me whether I will take it or not. So this is this little bit of AI, very primitive level of AI, of course. These are in our day-to-day life, knowingly or unknowingly, we all are using it. But all on a sudden, we are all started talking about AI and become very interested in the development of AI as an academia, as students, researcher, because of this model. So all of this actually either GPT-1 or GPT-2, they dealt with a mere 1.5 billion parameters. Parameters are the data points of training. Then GPT-3 when came into picture from OpenAI, because that was a huge battle. Facebook was fighting, Google was fighting, OpenAI was fighting. But finally, OpenAI won the battle with the introduction of this GPT-3 model. It's a dinosaur in compare with GPT-2. They took 175 billion parameters or data points to train the model. And rumor is that this is on the air that GPT-6 is also ready with 600 billion parameters. So more are the data points, more specific will be the answer, more it will be like a human writing. Till date, there are lots of tools that can detect you have taken help or not from an AI writing tool like originality.ai. Authenticate introduced a tool called EMA. They can rightly predict, identify what part is machine written, what part is human written. But again, in GPT-6, that won't be possible for AI detection tool because it will be so human-like with 600 billion parameters. But what happened, what changed happened because of this GPT-3 model, it can now write codes for you. In some day before. Professor Anirban Mukhopadhyay was talking one of his experience that he was busy with writing a code and could not find that what part of the code is going wrong. So after a little bit of frustration, he thrown the entire program to ChatGPT to detect the error. In which line the error is that? That was a logical error, not a syntactical error. And ChatGPT rightly pointed out this is the logical error actually happening in this line. So that is the power of because of this huge number of data points, it can write a code perfectly. You have written a code, it can rewrite it in a smart way. It can identify that what went wrong with your code. And more important thing, what I prefer or what I think a very important one from ChatGPT is the capability of creative writing. You give a theme and tell him to write a poem, it can do that. Although what is the literary value of that poem, that depends. That is a different issue. Every poem has not similar literary value, but it still it can write. You give a half finished short story, it can read it and it can finish the story. You give a plot, it can write a story out of it. So these are the very important thing, because so far creative writing was a challenging area for machine learning domain people, but it is now happening and it is fine tuned in each and every GPT model. Okay, so ChatGPT you already know. The point is that I can give a statement, I can ask a one-line question, it can produce a paragraph. But one particular things I should tell you that in your serious writing, you cannot consider ChatGPT as a good one, because suppose it can answer you the generic question very much. You write an essay on air pollution, it can do it, nice. But if you ask that a different kind of question, the relationship between air pollution and COVID-19 proliferation, it cannot answer you properly. So research question, you simply do not expect that the moment you are going deeper part of your research, the way you are going deeper, the way chat gpt is falling. So it can answer you set of generic text, nothing more than that. And that's also, it is not intelligently doing it. It has a lot of data points, it is summarizing the things, and it is actually giving you a summarized or merged answer kind of thing in a paragraph. The most important tools that you should use for your research, again based on the GPT-4 model, the same OpenAI, but trained with a different data set like Elicit. Elicit is a quality, question answer enabled, AI enabled QA service, question and answer service, which is trained with 125 million research papers. And again it's growing. So last week it was 125 million, I don't know, this week maybe 130 million. So every time it is successively learning from the research publication alone. Only journal articles and book chapter coming from Semantic Scholar, another AI enabled search engine I will be demonstrating before you. So that is a kind of tool. Do not try to use GPT, chat GPT directly or in the raw format, because most of you are depending on the free segment of chat GPT. It's not GPT-4, it's GPT 3.5. And this can produce at the base the generic text, which is not quite matching with your research depth or the research standard. So try to use Elicit. Elicit is completely, authenticated based on training data set. All is only based on, they have reduced the training part of GPT 3.5 and retrained the entire system with only research articles. And another tool is called Perplexity. So these are all based on GPT-4 model. They have an interaction with OpenAI in the program level, but they are using separate training database. Perplexity is one step ahead in the sense that it is not only utilizing journal articles, but at the same time, different kind of newspaper articles, different kind of blog posting, technical writing, technical reports, patents, and many more. So if you are in pure academic pursuit, Elicit would be a better choice. If you are trying to include some more relevant, socially relevant issues, then Perplexity is better because it can provide you at the same time research focus as well as different kind of comments, opinion, newspaper feature articles from experts. And you have so many times you have heard the this thing also, that computer can, you can give an instruction to computer, it can read your instruction, and it can draw according to your will. So this is DALL-E, again developed by OpenAI, and into, in the loving memory of Salvador Dali, a Spanish surrealist painter, a very important, in the history of painting. And there is another tool called Crayon. Say, for example, this is the URL of this DALL-E. You can go there, but I don't think presently they are supporting any new member except payment. So initially we tested it a bit, but still date I can enjoy my privilege there. So I asked DALL-E to design a library reading room with a soothing color combination, the provision of natural light, and a picture of Ranganathan on the wall. And it knows who is Ranganathan, how a library should look, what is the soothing color, and what is meant by the provision of natural lighting, and designed a cozy reading area for the library. If you are not getting access to DALL-E to check these things, a poor man DALL-E is there, that is called Crayon. It's not as good as DALL-E, but still you can understand that the process. You can write an instruction and it can do things on behalf of you. So before entering into the second phase of my demonstration, so let me cover first the generic tools, what I discussed so far. Then I will be coming back again to the domain specific application. So first I asked about you that Elicit, elicit.com. So here there are lots of facilities. You can upload a group of PDF file, and from that PDF file you can ask a question. You can, against your answer, you can ask a list of questions, concept related to a particular concept and so on. But most of the cases we people use find papers. So it's also a search engine, but AI enabled search engine. Why I'm saying that it's an AI enabled search engine and taking the help of this one, let me see. Okay, so I am asking a research question. What will be the future of scholarly communication process in the era of AI ML? So it's kind of a research question. I am writing in plain simple English. What will be the future of scholarly communication process in the era of AI ML? What it will do? You can see here. It talks about 125 million academic papers, providing result alongside this, with along with their DOI. All of this data is coming from Semantic Scholar. How many citations this papers retrieve? Then you can also export the entire thing in BibTeX format, so that you can, you know, you can select and you can export inside your Zotero or any reference management software. You can add column, say alongside this abstract summary, etc. I also want to know the limitations of the paper discussed inside the paper. So another column will be added with limitation, and in this way many of this type of column I can add. That's a beautiful facility. And then I can export all of these things, and you see here any of the paper I select, I can copy DOI, I can enter inside my Zotero, and in Zotero it will be fetching, data will be fetched as the metadata mainly. And if I still want to know more about this particular paper, so it will tell me that artificial intelligence, this paper details will be coming with introduction and everything. If I further want to know Semantic Scholar, if I go to Semantic Scholar, I can go there and I can check my paper. Semantic Scholar is also an AI enabled search engine, which gives you a process called TLDR. So it can give you the details of the paper along with its TLDR. TLDR stands for too long, did not read. That means it's a technology developed by Semantic Scholar. Semantic Scholar is founded by Paul Allen, the co-founder of Microsoft, way back in 1970s. So he left Microsoft at the age of 60, enjoying his holidays in Iceland, and donated a huge sum of money for the development of this Allen Institute of AI, Institute for AI. They come up with many products. One of the product is Semantic Scholar, an open access AI-enabled search engine, mainly scholarly search engine. So TLDR is a technology where a machine reads the entire document and gives you a one-line summary. So how it is going to help you? It can give you an idea that on the top of which this particular paper is written, whether it is important for you or not. If you want to expand, the whole abstract will be coming. And please do not think that this TLDR is a one-line summary of this abstract. This is one-line summary of the entire paper, and machine has done it. And apart from that, it gives you all kind of uh, citations and references. Say I am interested which paper cited this paper, so these three papers cited this paper, and again the TLDR, whether the PDF file is available or not, everything you will be getting from here. Then what are the references included in that paper? That is also it will be given. And what are the related paper related to this paper? So again, you can see these are the machine. This is a machine based recommender engine. Again, an AI enabled recommender engine. On the top of the similarity of the subject content, it actually suggested you these three papers. You can move to the next panel to get another three papers. These papers will be having its TLDR. If you think this paper is important for you, you click it, the details of that paper will come in, their citation, their references, and their related papers. So it's an excellent tool, Semantic Scholar, and Semantic Scholar is closely integrated with Elicit. And Elicit, what additional it can give you, you can ask things in natural language, and it is only based on this one. Now suppose the same thing I am asking, the same thing I am asking to Perplexity also. You see the difference between this Elicit and Perplexity. If I ask it is the same question, what will be the future of scholarly communication process in the era of AI/ML? It will not only utilize the scholarly publications like public, journal article, book chapter. It will try to give you a comprehensive answer, and you see every time data is coming, from where it is coming, it will be given in references. ChatGPT do not care about references, so that's why you do not know whether it is the right thing or wrong thing. But in case of Elicit or Perplexity, everything they are taking from some sources, just like our own academic writing style. We always give references from where we get the data, and any of this the number three reference you want to see, and you click that hyperlinked one. So this one is a coming not from a journal article. You see, it is coming from a blog post running by a very reputed scientific society or learned society, the Royal Society. So it's not a journal article, but or a book chapter, but it's a technical blog site. So this part is included in Perplexity. What is missing in Elicit? Elicit only considered the published material, but this Perplexity considers publications as well as different kind of technical blogs. Okay, so these two tools, you please explore, and Semantic Scholar, so you just compare mentally that what Google Scholar can do and what Semantic Scholar can do for you. Three, four things are different in Semantic Scholar. One is the TLDR. Second is then in one window you are getting all the citations and details of all the citation paper which actually cited your target paper, and all the references included in your target paper, and a machine enabled recommendation, a set of papers recommended on the basis of some algorithm, AI enabled algorithm. So these three things making a huge difference between Google Scholar and Semantic Scholar. Google Scholar is still huge in size, almost 340 million, But Semantic Scholar is presently is not up to that level in coverage. It covers only 216 million research papers, but service wise it is really great. Say for example, I am searching something like arsenic pollution. So if I search arsenic pollution, one beautiful things apart from this, facilities in Semantic Scholar is that most of the research nowadays interdisciplinary and multidisciplinary. So arsenic pollution may be viewed from the domain of chemistry, from geology, from groundwater engineering, and many more. So I can consider that my domain would be geology. I want all the research paper or arsenic pollution from the geological point of view. So now it will be classifying your result 119 only from the originated from the subject field geology. Then I want only full text has PDF. I can sort this by most influential paper or paper by citation count. That I can do. And all of these are not costly thing. It's completely open access. Even a database, very costly database like Scopus or Web of Science cannot give you this kind of facility. Hmm. So this is the things that is accessible, and these are AI enabled because any of this paper I can open up. You can see arsenic poisoning in Ganges Delta. So it can provide me the TLDR of the paper. Uh, I already explained 381 citation it received, all the details of all the paper which cited this paper, references included, and definitely the related papers. So these are the facilities not even available in very costly scholarly database like Scopus or other thing. And this is the first of its kind, you know, AI-enabled search engine with TLDR features. So now, if we already covered this one, so let me show you one beauty of this DALL-E. Let me give a text corpus. Okay, if you record data set, I am copying from other folder. So here let me show you that how I can use DALL-E. And as I said that DALL-E may not be providing free access to you, so you can try on. So if I go to DALL-E, what it is that DALL-E 3 is now also available. So I am instructing this tool to draw a picture like this. Draw a picture in front of Victoria Memorial, Kolkata, and imagine it is snowing heavily, and in the front of the memorial building, a yellow city cab is there. So how many of you have seen the frontal part of Victoria Memorial? All of you. Can you recognize it, whether it is doing it right or not? Okay.
Yes.
Yes. So now you see, I have given a few facts. Victoria Memorial, city is Kolkata. These two are real object. Then YOLO city cab, the ambassador taxi, yellow color taxi only available in India in the Kolkata city. And an imaginary situation. It's snowing heavily in front of Victoria. It never snows in Kolkata, but still I am imagining that. So let us see how it handles this thing. And you will be always wondering that how easily it is doing this kind of thing. It will take a few seconds only. It will give you different kind of plates like illustration, a sketch. So here these are the sketch comings, Victoria Memorial and other thing. But at the same time, you can have a plate like this kind of real life scenario. So YOLO city taxi, numbering, number plate, frontal part of Victoria, and many such plates you can opt for. So this one, amazing, or even in black and white. So now you understand how deepfake works. You just give this kind of free tools, which I am enjoying as a early tester of the tool, or anyone can access through minimum amount of money. So I can create this kind of real life imaginary situation where I can prove that it is snowing in Kolkata. So deepfake happens in this way, in a more professional manner, but the technology is the same. So any of the this kind of real life picture, a kind of flow chart, we can generate through these tools. It can understand what you are saying, and it can produce images like this. But these are all we are playing so far. Now if we come back to our initial domain target, you know we have another half an hour. So, initial domain target. My understanding of AI applications in scholarly communication is greatly influenced by this lady, Linda Gordon, a librarian of New York State Library presently. She actually proposed a set of, or actually forecasted a set of things rather, that what changes are coming in the scholarly communication process, and how libraries is going to tackle this particular thing. Like she recommended that most of the cases retrieval will be changing from the present days vector space model to large language model. Then content indexing will be something different, not the present cataloging, indexing, classification we are doing. Document matching, that is the search and retrieval techniques, is going to change like anything in future. Most of the cases you will be getting lots of AI algorithm based on the citation network. This is exactly happening presently. Content summarization, content writing will be dominated by AI, and quality of services, mainly information services, may greatly enhanced by this kind of tool. So, on the basis of her writing, I grouped all the tools in scholarly communication process according to the train of characteristics from simple to complex. First, I already demonstrated you Semantic Scholar, Elicit, Perplexity. This is a simple most tool. You do not have to install anything. You just use your browser, you register inside the system, and you are enjoying the fruits in a different way. And you already have noticed that how advanced these tools are. Then the second category of tools that we can explore, that on the basis of a set of core records, how can I enhance my code data sets for literature review, for literature gathering almost instantaneously by using different kind of AI based tools. Again, Linda correctly predicted this kind of tools will be there, which will be using citation network through AI algorithm. So that is, again, you do not have to install anything. You just need to register a news. You simply need to know what you are doing and the different kind of browser extension. So one recommender engine, like you are searching something that is available in closed access, you cannot have the paper. Sci-Hub is not providing anything beyond 2020. So what are the alternatives? So lots of recommender. One such recommender is core recommender, cooperative repositories developed by GISC UK. GISC UK is equivalent to UGC India, and different kind of citation grouping like site. So these are the browser extension we can use, again free of cost. And please remember, every tool and every services I am going to demonstrate before you here are all open access, all open source. Anyone can use without any legal or financial burden. So what I'll be trying that from each group, this group I already covered. So literature gathering under group I will be covering research rapid, but I also request you to take this tool, Insightful, iris.ai. Iris.ai, they are presently giving you a queue list. You register today, 7-10 days after you will be getting access to this tool. But it's worth trying. But this Insightful and research rapid is completely open. The moment you register, you can use. and I'm going to show you the activities of the browser extension. So in the group B, what I am going to demonstrate again, two, three things: that automated systematic review, and sentiment analysis, and machine translation. Most of the cases, sentiment analysis is basically opinion mining. Suppose you are having a large group of, you are doing a social science survey, a survey work in social science. So a lot of user comment or comment from questionnaire you are getting, and you want to classify those comments against a particular research question: positive, negative, or neutral comment. So a machine can do on behalf of you through AI enabled tools and technology. And here we do not have to install any machine learning backend. Please remember, installing, configuring, running a machine learning backend is a costly affair in terms of knowledge, in terms of time, in terms of money, because most of the cases this requires huge amount of RAM or hardware power. What I am going to show you, I will install a local software, very lightweight local software, that is called a data wrangling software. And by using the available free of cost AI enabled services and tools, I can do the same thing, like very costly, processing like sentiment analysis, data reconciliation, or machine translation. So I'm going to show you sentiment analysis, automatic sentiment analysis, and machine translation. And another things I'm going to show you, if time permits, that automated systematic review. There is a beautiful tool called AS Review that we can throw a set of documents. We can train the model. So these are the relevant, this is not relevant. And on the basis of that, it can rank documents, that on the basis of the training, these 1,000 documents you have given or 2,000 documents you have given, this is the ranked list of documents helpful for your literature review. Then you can decide that I will go for up to the top 50, top 100 for literature review. So this is the group B tool. And in group C, I'm not going to show you that how it works. I will just explain how it works. So here, one of the problem of AI ML is that most of the AI ML technologies are black box technology. Say, for example, you are using GPT from OpenAI. That's not an open model. They given the name of the company OpenAI, Open Artificial Intelligence, but the backend is not open. You cannot utilize an open source software backend like TensorFlow. So most of the cases, these are commercial adventures, commercial initiative, and black box technology. So fortunately, a few open source tools are available in the frameworks are available in the open domain. One of these tools is called ANIF, developed by the National Library of Finland, and I will show you in live mode that how, so that you can get an idea that how categorization is working in real life. So our major target is the group A and group B tool. So let us now concentrate on Research Rabbit. Before that, let me explain you what I am going to do here. Say I have around what to say. Okay, say I have this 39 number of document in my Zotero. Zotero, you already know how a reference management software work yesterday. So I'm starting my Zotero. It's a open source reference management software. Anyone can download it from here, zotero.org. Sorry, not zotero.org. So here you can download, and it's actually available in Windows, Linux, and Mac, all format. And the moment you start in Windows, right from them, there is no difference between the Linux and Windows. Here, there also you will be getting a thing like this. Now you see, I have collected around 40 numbers of references through Zotero I created. So let me import this one. I can import in BibTeX format. So desktop presentation 2024 CIRM. So suppose this is my target version with the 39 number of items. So this I collected This I collected, this is a CSV file, so I need a bib text file. Okay, let me try with this one. So I'm giving name this particular file CIRM. I have 26 number of items, CRM 26.b. So that you can understand that how I am doing this. I am importing this one, CRM 26.b. So what does it mean that any of the reference management software, yesterday possibly you have gone through Mendeley. Mendeley is a freeware, Zotero is an open source. They do the same things, reference management. So there also you can develop a collection of your core papers. And one thing I am giving you a precaution, please remember that any 2025 document you please do not include. You initially first 2025 documents, you read it thoroughly, you consider whether it is valuable for research or not, whether it touches upon the core part of your research or not. So on the basis of selection criteria, you select only 2025 documents, not more than that. It is not required, but that 25 document must be the core papers in your domain. So here you see my domain of research. In this case, I have taken as a group of paper from one of the ongoing PhD work. So that PhD work deals with the different kind of machine learning based uh, indexing term prediction for LGBTQI resources, library services for transgender community. So I have around 26 number of core papers which are dealing exactly the core part of my research of our research work. So here you see I can add very easily a particular paper. Say I have 26. Let me add another paper from Semantic Scholar just to show you that this is one of the beauty of Zotero, how easily you can add paper. So I'm searching by LGBTQ library catalog. So suppose this particular paper I want to include. Maybe the first paper. This paper has got an DOI. I would like to add this paper, Transgender Subject Access History and Current Practice, a very important paper. I consider it is a core paper in my domain. Let me check whether I have this paper or not. So what I will do, I will go to Zotero. This second item, you can search a paper by DOI, ISBN, etc. And the moment I give it, this is now the responsibility of Zotero to fetch and get the paper for me. So transgender subject access, it fetch, it's I rightly identified it's a journal article, is the title, author, and so on. So now I am having a 27 number of papers. I can now rename this. So now you see here this paper I can now export and export the entire collection as a bibtex format. And suppose I am giving a name. This is my version 1, V1 with 27 number of document. It's available. I am placing this one in CRM folder. Okay, fine. So this is the process. I have collected only 25 number of documents which are core paper according to my opinion as a researcher of the domain. And now I want to gather another 100 papers very quickly on the basis of this 7 number of papers. So my suggestion, if you manually search for relevant paper and include in Zotero, it will take almost a month for you. That I can do within 3 minutes with the help of a tool called literature map tool or literature gathering tool based on AI technology. As Linda predicted correctly, that citations algorithm will be dominated by AI in future, and it is happening actually. So I'll go to my favorite tool, Research Rabbit. Uh, Let me make it a clean slate. So nothing is there. You first create a collection, say CIRM 1, and this collection includes nothing. So what I'll do, I'll click add papers. I can search by DOI, PMID, etc., or I can upload my paper, through BibTeX or RIS format. So BibTeX we have already created. CRM, I don't know, it is 26 or 27. We have given V1 27. So V1 27. So all this paper, it may ask you that for this paper, I am not getting any valid DOI. Okay, you just click add this paper without proper DOI or not. It does not matter for me. So all 27 paper it included. Now you see collection is 27. And automatically, this is AI enabled tools. I can check the abstract of the included paper. It created what are the similar works that I missed, what are the earlier work in my reference span, because suppose my reference span is 1977 to 2021. So what are the earlier publication beyond, before 1977, and what are the post 2021 publication that I can get earlier and later work. It also saying that 27 papers are authored by 34 number of authors, but I can suggest you another 230, 63 number of authors. They have written something on this topic. Very good. Let us check. So first, my request is that explore, always start your exploration with similar work. The moment I select similar work here, I can also check this abstract so that I can read abstract. And now we need to understand how to read this network. So it created a networks of your paper, and you can see if you look at closely, there are three colors dotted. One is the, or four color rather. One is the deep green, another is the light green, one is the deep blue, another is the light blue. So green paper, be it dense or light, you have actually added inside your paper. So this 27 number of papers are represented by green nodes. You are already having this paper. And you see the nodes are in different size. That size actually it is determined by the system on the basis of the citation a paper received, how many nodes it is connecting. So that nodes are citations, basically citing author, cited author network. I include your paper in my reference. That means you are the cited author, I am the citing author. So on the basis of this simple network, it actually created the calculated the size and impact of the paper. This is called bubbles or not. This blue bubble I missed. So suppose this denser and bigger bubble are more impactful paper. So suppose this is a central paper in between in my paper, but I missed this paper. If I select it, this is the paper. Are we on equal terms? You read the abstract or click to check the full text of the paper. If you are satisfied, add to your collection. So now I am having 27 plus 1, 28 paper. Then this is, I think, a central paper. Node is central. Then add. So in this way, I can go on adding, paper that I have missed, and otherwise it may take me, and still there is no guarantee I will find out all the relevant papers. But this citation network, AI-enabled citation network, is making my life easy like anything. So you see here, the moment I add a few papers from the missing papers rather, and you don't have to worry whether you have included it or not. So suppose I included already it. So if I included it, it will tell me that removed from network. So the moment it says, you know that it's already there. So now you see, if I close the similar network now my collection went from 27 to 34 within seconds. Similar network is again different. Every time it is dynamic. You are adding a paper means you are actually, the network topology will be different. Now it is earlier work is 34, later work is 311. So if I go by the earlier work network, you see again the same is the clue that what earlier paper I am missing. So blue, you please read the abstract. Here I am doing things blindly to save time. So this is the earlier work. I have taken a few paper. Then later work, I can take a few paper. So now you see, slowly, my network of papers is becoming very compact and very easily actually. So later I am taking another 3 papers. You can go on taking. I just want to convey you the methodology. And again, I can come back to the similar one. And now you see, it is saying that, okay, these are the core paper you are missing. So I can go on adding another 2, 3. So you remember we started with 27 number of document, and now you see within a few minutes my network goes like anything. Okay. So now you see it is now 45, almost 2025 I have added. Now this 45 is authored by 57 number of authors. So another 271 it is supporting. It does not mean that this all 271 are the core researcher. One author may write different things in his or her lifetime, but it is saying that these are the highly producing author or prolific authors whose papers I missed. Say, as a researcher of the domain, I know this Melissa Adler is a very promising researcher in the domain. All the papers of Melissa Adler is not related to LGBTQ, but if I see all the published work of Melissa Adler, and I can see what are the related paper written by Adler, impactful paper I missed. So this paper I missed badly, which is very close to my network. This is also, but abstract is not there. So this paper, let me see. So I'm not taking anything without abstract. Okay, so in this way you can move to other authors also. Again, you can close this one. Now you see the network, you can attempt the Horsland papers. So it will tell you that what are the important papers on the domain written by Horsland is actually missing in your collection. You can add 1 or 2 more impactful paper, higher bubble, bigger bubble in the paper, and I can now close all this thing. So now I am reached to 50. So we started with 27. Within a few minutes we reached 50. Now I can export this one in BibTeX format. Maybe I can give a name, say CIRM. Say this is CIRM 2 with 50. So nomenclature must be in such a way that you understand what is the latest one. And now I can delete my 27 because this 50 includes this 27, and uh, import the new one. So this is CRM2, all 50 will come. And again I will work with my PhD work, will find other important papers, I will add to my core collection. Suppose it will become 60. Now with that 60 I will again go to research rabbit, and research rabbit will find other missing papers and can help me in collecting or gathering this kind of tools. So it's a beautiful help, completely free, open access. You need to use it judiciously by integrating your Mendeley with Research Rabbit or Zotero with Research Rabbit. Zotero I prefer because it completely open source, And this facility is not available in Mendeley, that you add a paper through its DOI. It's a magically it works like. So you already know how to export, how to import, how to integrate with Research Rabbit. Okay. Any question up to so far, up to this level? So now we are moving to the next category of tool, which is the browser extension. So again, this browser extension are just Firefox or Chrome extension. So let me show you how my browser is different from your browser. Say I am going to a very famous commercial portal called Science Direct. Most of the science students knows this portal. This is the full text platform of all 1200 plus journal of Elsevier. So I'm searching something again, say arsenic pollution here. Now it read tip papers. Some are open access, some are closed access. Mostly these are closed access. Say suppose this research article I think important for me. Human-induced arsenic pollution modeling in surface water. This is a completely close access paper. I don't know. Anyway, so suppose I am selecting a paper which is close access. Say this research article. I don't know. So it is also giving me abstract. Okay, no, it's completely close access. It is saying me this is only abstract is available, not full text. But you see here under AI enabled recommender engine from core repository. So I need to install this core recommender in Firefox. So it can tell me that this paper I cannot provide you, but I found similar paper. You can check it from here. And this is saying open access button. If any open access version of this paper available, it can immediately notify me. This is called open citation corpus, number of citations received by this paper, it can tell me. And this is S-site. S-site can tell me what is the total number of citation received by this paper, how many of these are openly supporting the views of author, how many of these just mention the author, and how many of these contradicting the view of author. When you are citing a particular paper, your citation may fall into three categories. You are supporting the view of the earlier researcher. You have just mentioned in your literature review, I have gone through this paper, people reported this kind of thing. Or I am contradicting the views of a paper, earlier research result. So citation may be of three types. It can categorize citation, and it can provide you in real-time measure of a particular article, any of the article. And this is a code paper. I can click that similar paper available or not, and it can tell me that what are the papers available. So let me check again with this review article what is happening. So again it will take a few seconds to tell that citation is 4. This is the similar paper available, and we can go for it. So same is the case with Google's Chrome. So you can install different Firefox the same article I am opening in Google Chrome, and I have installed similar tools there like a site, and you see result is the same. Similar papers are there. I can go and check, and these are the it automatically here unpaywall button I have also utilized. It says that this article is not open access, and this is the similar paper. If I click, I will go to the code domain. So this is very simple, but many of these are AI enabled tools, and you can utilize this recommender engine, this browser extension. Now if I go to a more important thing, everything I may not cover today. Let me today try to cover you only this sentiment analysis and machine translation automatically. So there, what the tool I am using, an open source software again, and as we said that we actually kept in mind that it's a very easy to use tool, run both on Linux and Windows operating system. So one such tool is called OpenRefine. Previously it was called Google Refine, and now it is called OpenRefine. You can say this OpenRefine is a next generation spreadsheet program like MS Excel, but far better and far powerful than that. And typical Excel functions are not there. We use this software for different other purposes, like to integrate with the backend machine learning system through REST API based collection and other things. So you can see here, you can download for Windows version, Mac version, or Linux version. If you are using it in Windows, please install with installer. It will include Java. You do not have to need Java separately. But if your machine is already having some kind of Java version, you can also use this without Java, without installer. So after downloading, what you need to do in case of Windows, you just double click, it will open. In my case, in case of Linux, I am going to my folder and opening my OpenDefine. So first I will show you that a machine learning tools which can do sentiment analysis for you automatically. Okay, so I'm clearing the things a bit. And what I will show you that I have already collected a text data set which includes reviews related to different books. And I also collected a set of 40 items which are we are presently developing a vocabulary for LGBTQI resources. So I collected a few terms related to that. That I will show you that how I can translate the descriptions automatically. So, okay. So how to, these documents are available in CSV or TSV format. So let us first do the sentiment analysis. So I need to create a project. It's a very easy to use software. Just you need to understand what you are doing. So desktop, then presentation. So here I am first going to use this sentiment data set. And I already told you this is nothing but a data set of book reviews. So this is the review text. Somebody is saying it's a good book, somebody is saying it's a bad book, and so on. Now you imagine that the same situation happening with your a big survey. People recommended different things, people opine different things. You want to categorize how many are positive, negative, or neutral. So you can take, you do not have to have a machine learning backend of your own. There are lots of free services. So one such free service is created by European Union called Dandelion. And Dandelion, you can register yourself. The moment you register, you will be getting a API token like this. And that token I can utilize in API formation. So that you see, these are the services it's providing. It can gives you similarity score between two text for plagiarism detection. You can automatically detect language of a document, or you can determine sentiment of a given text. And the moment I click sentiment analysis API, so it will tell you that what is the API end URL, and this is the end URL, and how you can utilize your token. So on the basis of this reading, it's a very simple thing. Once you read, you understand, and please you check what I am doing. Say I on the base, I will throw this text, and but this is a 2,000 document. I don't want to throw everything to save time. So what I will create, I will create a column, add column based on this column. Say I'm creating a column called ID so that I select any 100 document in between. So row dot index plus one. What this is basically this row number I am just reproducing as an ID number. So ID 1 to 1973. I want to select top in between 100 documents, 100 books. Say 900 100 to 1000. Okay. So what 901 value less than is equal to 1000. So this will produce the condition will produce this. For this it is false. So for 950 it will be true. So the moment I click OK, it will create two facets. So 1873 is false, 100 is true. That was my target, to give the this 100 matching rows. Now what I am doing, you know this already. This is the API URL. So I will add column by fetching URL. Then say, so I'm using this URL, API end URL, by reading this manual. So this is language is English, and text I'm throwing in URL decoded format, and I'm using my token. So in your case, your token will be different. You just register, you will get a token. And I'm giving this column name Senti data. So what it will do, it will read the text one by one for this 100 matching rows, and will give you result in returning back in JSON format, JavaScript object notation. And that's a simple data exchange format. I will show you how from JSON format I can deduced result, whether it's a positive review or a negative review or a neutral review. So you see how lightning speed it is working. You can throw 100, 1000, 1 lakh, 10 lakhs, no matter. Only more time it will take. So now you see, it actually gave me data. This is the JSON format data. So sentiment, without the sentiment, there is a array called type. So what I will need to do, I can create a column again, add column based on this column. Now senti type is my column name. Then value parse, it's a JSON data, so I'm parsing JSON. So this will give you the array. Then within the array there is a element, data element called sentiment. Now within sentiment there is type. I need this type, negative or positive, dot type, and I can now click OK. So one column will be created, senti type. So in this 100 document, now I can go for facet analysis to tell that how many are negative, how many are neutral, how many are positive. Now I want to select only books with the positive reviews. The moment I select, this is the 37 number of documents which are having the positive review in this 100. And now I can export this 37 in CSV, TSV, and so on. So another, this is one thing. Another thing you see through this data wrangling tool, these tools are called data wrangling. I have data sets of this 39 number of documents. So I want to translate here. How many language peoples are available apart from Bengali and Hindi? Any other language you know? Indian language? So that we can try something in different language. Any Dravidian language? No? Hey, am I connected? No. Okay, I am asking a question. How many of you actually know a language different than Bengali and Hindi? Like any Dravidian language, or somebody is saying Oriya language. Okay. Anything else? No. Fine. Okay, so let us try with Bengali and Oriya and Hindi. You can see how I am doing this. So here I am using again a machine learning backend called, nowadays translation is not, word by word or sentence by sentence. It's basically it is taking different kind of memory based AI enabled translation. So one such tools is called my memory translation, my memory. So this is a translation, framework. Say, okay, let us say that I am having this TSV file, and say I am trying to see from the user interface, say feminism, whether it is rightly giving this one. So I can paste this one, the definition of feminism. Language, I can set auto detect. Then suppose here only one Indian language available in this search interface, say Hindi, I think. Let me check whether it can do it or not. So this automatic translation is a remarkable, research tools you may have. Suppose you have identified a Polish literature, very important document, and you do not have to, you can't provide the cost of translation because translation is very costly nowadays. So the methodology part, the introductory part, the research problem part, you can copy, you can create a CSV file with different components, and you can throw or utilize this kind of system. Because for one, two document you can do this, but suppose you are having more than 3,000 document, it's not possible. So we need to find something, some tools that can do it automatically. So it is translating this definition of feminism in this Hindi, but I want to do in other Indian language from the same platform. So what I will do, I'll create a project again. So this is available as a translation demo data. So I'm going to my folder, and see, this is the translation demo data. I have only 39 number of terms. And you see here, as we are developing a vocabulary, we have URI of the term, we have identifier, term identifier, pref label, and description or definition or scope of that particular term related to different sexual identities. Because nowadays it's not a binary one, it's a still spectrum one. So we're trying to develop a vocabulary out of it, and I want to translate this description in Hindi, Bengali, and Odia. So you see how I can do that. I will take the help of this my memory, add column by fetching URL, say DSCBN, and another one I will take. So again, I am doing data fetching from my memory. Then I am throwing the text and language pair from English to suppose BN. BN here stands for the ISO code for Bengali language. OR is the ISO code for Oriya language. And if I give OK, now you see it will start querying this, throwing this particular things, 39 number of rows or data to my memory, and it will fetch JSON data automatically. So this I am doing for Bengali, and then we'll check how far it is matching. Or but backend is the AI enabled. I am not using that AI enabled, not installing that platform, because that's a very, very costly initiative, hardware wise and other things. I'm just using it in a clever way. Then I am trying to do this in Oriya also. So again I am repeating this, but this time I will change that, not in Bengali. Can you do it in Oriya? So OR is the ISO code for Oriya. So make it DSC OR and click OK. So now it is doing for Oriya, and you can see in Bengali it gives you some kind of Unicode garbage, but it's not garbage actually. This is Unicode coded JSON response. So we can always parse this one, and parsing. So Oriya came and Bengali came. Let me first change this from to meaningful thing, so I can transform, and I can say that okay. So let me parse this one. Value parse JSON. Now you can see Bengali is coming. Value parse PAR. Now you see Bengali is coming. So within this, I need this response data, and within response data, translated text. So dot response data and dot translated text. So now you see it is converted into Bengali, and the same way I can convert into Oriya. Now someone from Bengal will tell me that whether it is matching or not, and someone from Orissa will tell me whether it is matching or not. So let us take the example of feminism. In feminism, it says this is the original English, this is the Bengali translation, and this is the Oriya translation. So now let me confirm whether it's right or not.
Yes, sir, the Bengali translation is correct as per the description of feminism.
Okay. And for Oriya, anyway, I think that now you understand the power of this AI/ML and the utilization of a middleware like OpenRefine. OpenRefine is a very powerful, helpful tool for research, both for social science as well as science and technology people. You can do automatic translation, auto summary. Suppose one particular system is giving you auto summary. You have a text, a full text of the document. You can throw and it can summarize. I can utilize the OpenAI based, REST API syntax in my OpenRefine to do things automatically for larger number of documents. So today, up to this, I will try to take another class next someday. So if you have any question, please do not hesitate, or otherwise we can go for a break. Any question so far for today's related class? Any question in the chat box? Okay, then. The next session will be taking place as per the schedule, and I will be there to introduce the resource persons. So, thank you very much. I'm closing this.
Thank you.
Okay.